Welcome back to the deep dive. Today we're digging into some really specific notes, actually.
Yeah, very specialized stuff.
We're looking at scientific curiosity versus maybe just plain gardening efficiency. It's all about one single seed sowing journey.
That's right. For the peacock flower, Caesalpinia pulcherrima. Very vibrant tropical plant.
And the source material. It's interesting. It's not really a how-to guide, is it?
No, not at all. It's from this series, Notes on Gardening. This is part 667, so clearly part of a long-running thing.
667. Wow.
Yeah, and it documents the start of an experiment by this gardener, Ang. And importantly, the notes mention this wasn't totally out of the blue. It connects back to earlier thoughts, parts 263 and 505.
So a long time brewing, this idea.
Seems like it, a culmination of thinking about it before. Okay, so here's our mission today for you listening. Ang made a choice, a deliberate choice to ignore the usual advice, turning what seems like routine planting into, well, a test.
So we need to unpack why that standard advice exists, the science behind it, and then maybe critique or at least understand the implications of just skipping it.
Right. What's the so what of ignoring the tried and true method? It's really a perfect little case study in testing assumptions.
And you mentioned that history, those earlier notes. That's probably key context, isn't it?
I think so. Those likely weren't just about, digging in the dirt. They might have been wrestling with how hard it is to even get this plant, or maybe thinking philosophically about tackling something tricky to grow.
That's the stage.
It tells us Ang isn't a beginner stumbling around. This is someone experienced who's now kind of pushing back against the established way, intentionally.
Okay, let's get into the trigger for this whole thing. The starting problem. Ang just couldn't find a small, ready-to-go plant at the nursery.
Mm-hmm. The usual starting point wasn't available.
So if you can't buy the plant...
You got to make the plant. That's that classic situation. Constraint forcing a different approach. Starting with a cutting or a seedling gives you such a huge head start.
Right.
Going straight from seed, especially with a species like this one that's known for being a bit stubborn about sprouting. Well, you're immediately up against the plant's own biology. Its defenses.
So the workaround was finding a mature peacock flower plant already growing somewhere and harvesting seeds directly from it.
Exactly.
But, okay, once Ang had the seeds, the next step was figuring out exactly what they were dealing with. The notes are pretty descriptive here, which helps us visualize it.
Yeah, the source is quite clear. It describes the seed pods first. Oblong-shaped, shiny, dark brown or black.
Okay.
And crucially, they hadn't split open yet.
So Ang got them before they naturally scattered.
Precisely, before the plant did its own self-sowing thing, which means the seeds inside were probably, fully protected, maximum integrity.
And the seeds themselves, once out of the pod.
Described as small, kind of flattened, bean-shaped, also dark brown to black.
Like little beans.
Yeah, if you could picture a small ornamental bean, or maybe even a lentil, you're in the right ballpark for shape and size. But the really important detail, the one that screams, hold on, don't plant me yet, it's the texture.
Okay.
They have a very hard outer coat,
right.
Known for it.
Yeah.
It's like, well, the notes basically describe biological armor.
Biological armor. Okay, that's the core of the issue then, isn't it? This hard shell. Why does nature even do that? It's not a mistake. It's on purpose.
Oh, absolutely. It's a feature, not a bug. Think of it as an evolutionary promise. This super tough, often drought-resistant casing.
Mm-hmm.
It makes sure the seed doesn't jump the gun and germinate too early.
Like after just a little bit of rain.
Exactly.
Yeah.
It needs reliable, sustained moisture. The kind that signals, the real start of a good rainy season, especially in tropical climates. If it sprouts too soon, based on a brief shower...
It just dries out and dies.
Right, desiccation. So the hard coat is a strategy for survival over the long haul. Sometimes these seeds can stay viable, just waiting for years because of it.
So the gardener's aim quick, controlled growth is basically fighting against the seed's own built-in patience. Its strategy to wait for perfect natural timing.
You got it. Which brings us neatly to the conventional wisdom Ang looked at. It's all about how to override that waiting game.
How to trick the seed.
Pretty much. To kickstart it in your nice controlled environment, you have to defeat that main barrier, the armor. Water has to get inside, to the embryo.
Because the armor stops it.
Often, yes. These coats can be hydrophobic. They actively repel water. Makes it almost impossible for water to soak through without some help. But water getting in, that's the trigger. It wakes up the growth hormones inside, things like gibberellins that tell the seed, okay, time to break dormancy and grow.
Right. So the gardening guides, which Ang definitely read, they offer two main ways to speed this up, to get that water inside.
Yep.
The first is physical or mechanical. Scarification. Sounds rough.
It involves literally scratching or nicking or maybe filing the seed coat. You're making a tiny wound in the armor, deliberately.
Like opening a door for the water.
Exactly. Letting it rush right in where you made the opening.
Okay, that's option one. What's the other? Option two is more chemical or thermal, you could say. Soaking. The notes mention warm water specifically for about 24 hours.
Ah.
Okay. With soaking, you're not necessarily breaking the coat, but you're softening it up considerably, making it less resistant so water can slowly, eventually seep through that wall.
And both methods basically do the same thing in the end. They achieve the same goal, get water inside faster. They save a huge amount of time compared to nature. How much time are we talking?
Well, think about what these methods replace. They replace potentially months, maybe even years, of natural processes like the seed coat slowly rotting in damp soil or freezing and thawing, or maybe being weakened by passing through an animal's digestive tract.
Right.
And they replace all that with maybe 24 hours of prep work on your kitchen counter. It's all about efficiency. Okay, efficiency. Which makes Eng's decision, well, pretty interesting, because this is where the experiment really kicks off. Knowing all that, Eng decided, and the notes say, quote, sow the seeds directly as is. Just skip the scarifying, skip the soaking, both of them. It definitely makes you pause, doesn't it? And for you listening, it raises that question. Knowing the biology, knowing about that hard coat, isn't Eng basically just signing up to watch damp soil?
Yeah.
For potentially months?
Yeah, I mean, we value efficiency everywhere else. This feels like choosing the slow lane just to see how slow it is.
It can feel like that, like an unnecessary delay, just for observation's sake.
I admire the curiosity. I really do. But if the end goal is actually growing the peacock flower, and we know that dealing with the coat first could save, say, 8 or 10 weeks, maybe more.
Yeah.
Isn't this just sacrificing success, or at least speed, to prove something we kind of already know, that untreated seeds take longer? That's a really fair point. It's a valid critique. But let's flip it slightly. Think about validation. Eng isn't just testing if scarifying works better. That's pretty well established. Eng is testing the necessity of doing it at all.
Ah, okay. The necessity.
Maybe, just maybe, these seeds only need that help in really tough, suboptimal conditions. Or maybe the specific seeds Eng harvested from that specific parent plant, maybe they have a slightly thinner coat than the textbook average suggests.
So it's possible they might sprout faster than expected, even without treatment.
It's possible. By skipping the treatment, Eng is collecting a baseline data point. What is the actual unassisted germination time for these seeds in this specific soil mix under these controlled conditions?
Okay, I see. So the experiment isn't about finding the fastest way. It's about validating the need for the shortcuts in the first place.
Exactly. It reframes it. Validation, not optimization. Eng is treating that common advice, scarify or soak, almost like a hypothesis that needs checking in their specific situation, even if it costs time.
That changes the focus quite a bit.
It does. The whole journey now isn't so much about if the seed will sprout eventually. Nature usually figures that out, given enough time.
Right.
But it's about how long that natural process takes compared to the quick methods. Given that super hard coat, we should definitely expect it to take longer. Weeks could easily turn into months for simple soil moisture to wear down that armor naturally.
It really does become a race then, a slow race between natural decay and the gardener's patience.
Yeah. Eng is now relying entirely on the slow, steady work of microbes and moisture in the soil to break down that shell instead of that quick shock from scratching or soaking.
And the notes kind of end on that suspenseful point, don't they?
They do. The last entry we have from September 26, 2025, it just ends simply. Let's watch how this unfolds in the coming weeks.
Perfect. The anticipation is the point almost.
The data collection itself becomes the reward in a way.
Okay, so that gives us a really clear summary of what we've unpacked in this deep dive.
Yeah, first the starting point. Eng couldn't get a starter plant of the peacock flower, Caesalpinia pulcherrima. That constraint forced the switch to seeds. Check. Then second, we looked closely at the seeds themselves. Small, dark, bean-like, but crucially with that very hard, water-resistant outer shell. Their biological armor.
An armor designed by evolution to delay sprouting until conditions are just right, ensuring survival. Got it. And third, the core of it. The deliberate experimental choice. Eng knew about the efficient shortcut scarifying or soaking to speed things up, but chose to skip them.
Right.
Opting for direct sowing to test the baseline, sacrificing speed to validate whether those shortcuts are truly necessary in this specific context. And we're left hanging. We don't know the result yet from these notes. but the implication is clear. Skipping the treatment likely means a much longer wait, a potentially very long wait. If soaking really does save, say, 8 weeks, that's a significant time investment Aang chose to make for the sake of observation.
It really is. And that leads us perfectly into our final thought, something for you to chew on. Aang chose pure observation, accepting that long delay.
Okay.
So imagine you're Aang, you have the notes, you know soaking works fast. Would you be more drawn to the patient scientific validation of watching nature take its slow course? Or
Yeah.
would you grab that nail file, scratch the seed, and get things moving now?
Efficiency versus understanding the baseline.
Yeah. Where in your own projects or your own learning do you lean towards the efficient shortcut? And when do you feel it's more important to really test the assumptions behind that shortcut, even if it takes longer? When is speed the priority, and when is deeper validation more valuable?
Something to think about until we maybe get an update from Aang one day and keep digging into your own sources.
And maybe keep testing that conventional wisdom sometimes.